Awesome. Thank you all so much. My name is Andrew Smith. Like you said, customer engineer for startups. That basically means I have the best job ever. I get to help startups get started with Google Cloud. I help builders architect out their solutions, make sure that they're aware of all the tech we have going on at Google. And ultimately, I'm here to make sure that they're having a good developer experience with demos, proofs of concepts. And we love building those and showcasing them to our customers, as well as the developer community at large through trainings and workshops. So I'm going to start with a little bit of background just on Google's models. So we have three kind of workhorse models when it comes to text generation. Gemini 2.5 Pro, it's really good for coding tasks as well as more highly complex tasks. We have 2.5 Flash. This is kind of our workhorse model. A lot of our internal stuff is being built using 2.5 Flash because it's a really good combination of price to performance as well as latency to performance. And then lastly, we have 2.5 Flash Lite. It's a super great model for high volume tasks. It's super cost efficient as well. I also want to mention that as of today, Gemini 2.0 Flash Image, which is kind of our image generation model, colloquially known as Nano Banana, you might have seen that in some of our marketing or in social media, that officially went GA as of today. So when we talk about Gemini inside the Google ecosystem, there's a lot of different Geminis. I feel like we're attaching that name to practically everything that we're doing. And for good reason. It's a really good family of models. For consumers, we have the Gemini app. So that's built into your phone on Android, or it's an app you can download for iOS. It's also the web app, available at gemini.google.com, just our consumer chat experience. We've got Gemini Code Assist, integrates into your IDE, providing recommendations based on your actual code base. We've got Gemini inside of the Google app, as well as throughout Google Workspace and Google Docs, Google Drive, and all those surfaces. And each of those are going to behave a little bit differently than each other. They all have prompts that are fine-tuned for their specific use cases. We're trying to make Gemini a helpful assistant no matter where you are. What we're talking about here in this talk is more for developers. So we've got two main surfaces for developers. We've got the Google AI Studio and the Google API and the Gemini APIs. And there's two ways of authenticating to those APIs. One is through an API key from Developer Studio, and another way is through an API key or service account from Google's Vertex AI from the cloud side. And of course, we have our other models that are also really powerful. VO3 for video generation, Imagine 4, Gemma, our open source models, and all of those super, super powerful models. Gemini 2.0 and beyond, so from Gemini 2.5 as well, has brought a lot of new features for agentic AI experiences. Things like built-in tool use, actually taking actions based on what you're asking them to do, as well as real-time streaming, where you can have a real conversation back and forth with the model. A little bit more information about Vertex AI, just in a bit the cloud side in general. Vertex AI is Google Cloud's managed end-to-end machine learning platform. So all of this is nested inside of Google Cloud. It's in your VPC environment. Everything that happens in Vertex is private and sterilized, enterprise-grade security, and enterprise-grade reliability. So from inside of that, we have a lot of different features, one of which is the Model Garden. So Model Garden has a ton of generative and predictive models from Google, as well as a ton of our partners and open source models. So you can single click to deploy any of these models on GPUs inside of Google Cloud. And also you can single click to deploy and get an API key to explore and kind of start building on a per token billing basis with a lot of our partner models as well. Google AI Studio is kind of a GUI interface where you can experiment with Google's AI models and some of our partner AI models as well. Sorry about that. So just single click to deploy, really easy to kind of go and play around with the various dials that you have to generate different outputs with the models. Next, we have a ton of custom model tools. So for traditional machine learning, we have all of the tooling you would need to spin up a training job on Google Cloud's platform, as well as host prediction workloads as well. We also have vector search for embeddings. We have Vertex AI RAG engine for performing retrieval augmented generation on Google Cloud. Colab Enterprise for kind of enterprise-grade hosted Jupyter notebooks. And all of this is kind of grounded with enterprise-grade security and reliability. So here's kind of a general look at what an API workflow goes through. So the user prompts our AI, It goes through some safety filters that Google has for all of our API requests, and then it's routed to our foundation models, which then can choose to call tools, do code execution, go fetch a URL to get context from that URL, feeds that information back into the foundation model. Then that response is filtered through our system. It'll either be rejected or it'll be sent back to the user. And whenever it's doing that, we also have citation checking that goes on. So we know that the response that's given to the user is grounded in materials. There's a super wide range of things that you can provide to the model as inputs. So system instructions to kind of get the model and tune the model to behave the way that you want it to, just in natural language. You can provide it text, code, images, audio, video, speech, and also API information. And then we have a bunch of outputs that are available as well: text, image, audio, video, or function calls to go get more information, or take actions within your systems. A couple of key things that I want to highlight. These models have native built-in multimodal understanding. You can provide YT links directly to it, and it can go and understand the content therein. It's got a super long context window, 1 million tokens for Pro, and also 1 million for Flash. 2 million is in preview. It also has a bunch of context caching. So if you're constantly sending the same request or similar requests, we will cache that context, and then we will bill you less for reusing it. And I believe we actually just decreased the price for context caching as well. I think it used to save you about 50%. I believe we raised that to about 75 or 80 as of today. We also have a ton of media generation models. Gemini 2.5 Flash Preview just went GA today. So you can provide text and images as an input and get images and text back as the output. Imagine 3 and 4, VO 3 and 4 for video generation. And also really exciting, I think, is our live API. This allows you to stream in audio and video to the model and then get text or audio back as outputs from the model. So I think that this can power a lot of really untapped use cases, like streaming an entire computer screen in order to provide tech support and such. Really fantastic kind of capabilities. All of our 2.0 and above models are thinking models. So this means that they're analyzing and breaking down tasks into subtasks before actually going and completing all the different steps of execution. Part of our Gemini API, as a part of that, we provide actual thought summaries if you request them. These can be super helpful for debugging your system prompts and kind of fine-tuning them to get the model to behave the way that you want to. I've got a little kind of code sample of what that looks like here. If you kind of request in our thinking configuration flag that you want it to include thoughts in the output, you can get those thoughts back, see what the model is thinking, and kind of use that to help fine-tune your requests to Gemini. A couple things that are new as of today. I won't be covering them very much in kind of the demo that I'll be doing here in a moment, but I do want to showcase them just because they're super exciting. Today we did launch Gemini 2.5 computer use. This is launching in public preview. This is a specially trained Gemini model and tool that's offered as a part of our Gemini API to interpret kind of the screen of a given computer and output navigation instructions. So it's available in public preview, both Vertex and in AI Studio. We intend on eventually kind of merging the capabilities of this task-specific model into the main Gemini model by general availability. And at that point, it'll just be offered as kind of a tool that you can call as a part of the Gemini API. Some of the benchmarking on this, it's performing super well in all the various benchmarks that we're showcasing here. And also is performing super well in terms of accuracy and latency. So lower and to the right is better in this particular case, higher accuracy and lower latency. So we're super excited to kind of see this go GA and to see what people build with it. And of course, this is all built on top of kind of the technology and the training that we've done with Project Mariner that was previously announced. So let's start with kind of a very basic question. What is an agent? You'll hear a lot of different definitions, but for the purposes of today's talk, we're going to go ahead and use this one. An agent is a system that uses a model to reason about and select the appropriate tools to achieve a specific goal. So when I think about kind of general agent architectures, I really like to think of 3 key components. You've got the model itself, that's kind of the brain of the operation. It's deciding, it's interpreting the instructions, it's interpreting all the context it has available to it, and it's making decisions on what to do next. Next, you have the tools. I kind of like to think of these as the arms and limbs of the model. This is the way that it goes and gets more information. Grounding with Google Search is a tool. Grounding with Google Maps data is a tool that's available. But also you can build custom tools. And I think this is where the LLMs become super powerful. Large language models kind of, by definition, are non-deterministic. You're not always going to get the exact same output given a set of the same inputs. So tools really are the way that you can work with the models to get repeatable, deterministic outputs. Creating tools that go and interact with your systems in consistent ways is super, super important to getting the most out of large language models. And to effectively use tools, we need some different orchestration pieces. We need something to maintain the memory and store the state of the conversation. We need something that kind of stores that plan, has all the tools organized, and provides all that information to the model, and also just for us to store and debug later. So as a part of this talk, I'm going to use 2 different kind of frameworks, and we're going to build a very simple agent together. So the first kind of framework we're going to be using is MCP, Model Context Protocol. That's the open source standard for connecting agents, AI applications like agents and assistants to external tools. Unlike the typical client library and server model where the user is responsible for their app connecting to an external system, MCP kind of acts as a proxy in the middle between the AI app, the client application, and the server, so the actual function that's happening, or the actual database perhaps that's calling. So in this case, we have an MCP client that can be, say, the Gemini SDK, that can be the ADK SDK. OpenAI's tons of different SDKs work really well with MCP. And then we have all of these tools that we're going to expose to it through an MCP server. And then the model, or the MCP client that's a part of our framework, like ADK, or part of the model's SDK directly, will communicate through JSON RPC back to this MCP server to do a couple of different things. So the first thing it's going to do is, whenever kind of the agent is initializing, it'll reach out to the MCP server and say, hey, what can you do? What tools are available to you? What tools are available to me in order to perform tasks? And then the MCP server is going to reply, hey, here's all the different things I can do. I can do ABC, fetch DEF from the database, generate HIJ, send JKL, et cetera. And then here's all the inputs I need in order to do those various different tasks. And then our MCP client is going to relay that information back to the model, and it's going to use that in its decision-making process. So a user's prompt will come in, it'll decide if it wants to use any of those tools to gather more information or to complete the action that the user's requesting. And then eventually, if the model decides it wants to use the tool, it'll go and make the tool call and say, hey, MCP server, I would like to do this. Here's my authentication information. Here's the information that you requested from the user in order to complete that task. And then the MCP server will turn around and actually perform that function code. Here's a look at kind of a possible agentic stack, everything kind of working together. The very top here, we have the agent development kit. This is Google's open source code-first toolkit for building, evaluating, and deploying AI agents. It's a really great framework. Integrates super well with the Model Context Protocol, MCP, which is the open protocol for how agents provide context, for how applications provide context to LLMs. And then we'll need a place to run it. In our demo today, I'll just be running it locally on my laptop, but Google does offer up the Vertex AI Agent Engine. That's our managed platform for running agents and kind of letting them automatically scale with your application in production. And then lastly, we also have the A2A protocol, or agent-to-agent protocol. This is another open standard. It's designed to make communication and collaboration between multiple agents seamless. So it facilitates the kind of transfer of context from one agent to another and allows them to kind of continuously hand off without issue and making the user repeat themselves over and over again in order to complete tasks. So let's build an agent. Let me switch over my screen share. This will take just a second. And let's just hop into an IDE and start building. I might disconnect and reconnect and get it just re-prompt me real quick. Awesome. So I'm just going to fire up VS Code, and let's start building together. Let's see if I can change my scaling options here. There we go. So first thing I'm going to do is I'm going to build out an MCP server. So in this demo, I recently kind of just asked all the major LLM models, hey, where is the International Space Station right now? And every single model that I tried provided an answer that was grounded in real time, that was grounded in data. However, the International Space Station is constantly moving. There's no, if they're using any sort of caching, which all of the major providers are, there's no way that they're going to get immediate up-to-date information about that. So all of them provided incorrect answers. Let's create an example MCP server that can provide us an up-to-date answer. And then let's use ADK to build an agent that is connected to that MCP server so it can answer accurately. So first thing I'm going to do is I'm just going to create a simple Python file called MCP server. And then I'm going to start initializing things. So I'm going to create a virtual environment here. That's created. Now it's activated. Awesome. And the framework I'm going to use to build this specific MCP server, I'm going to use FastMCP. It's a great framework for building simple. Maybe I should actually. Yep. Actually use the right command. There we go. And then I'm just going to get started building here. So I'm going to import it. And then I'm going to initialize it. I'm also going to import the requests library. Because we'll use that to query a real-time API about where the space station is. Next, I'm going to kind of just initialize my MCP server here. So MCP equals FastMCP. And then we can also give it a name if we want. In this case, I'll call it ISS location MCP. And then we can get started kind of building our functions to return the right data. So FastMCP uses decorators. So I can do mcp.tool. Then I can define a function. So let's say get ISS location. Autocomplete loves me today. Somebody used the request library to go out to this just open notify API. This is just a publicly available API that returns the location of the ISS. In fact, I can curl it right here. We can see the locations provided there. And then I'm going to return that to the model. So I'm going to do response.json. And then for fun, let's do another MCP tool that returns the crew info. Once again, autofill is my friend today. Same, different endpoint of the same API server here. And then I'll just add a, if name, if the name equals main, let's run the MCP server. And then for transport, in this case, I'm going to go ahead and use stdil. Perfect. And that is it. That is my MCP server. So super basic, but it's going to work, hopefully, if the live demo gods like me today. And now let's create an ADK agent. So for this, I'm going to create a folder. So this will be the name of our agent for kind of viewing in the web. Then I'm going to create an agent.py file. And this will require a few imports. So first I'm going to go ahead and install ADK. So pip install Google ADK. Go grab all of that information from the server. Then I have a few imports on this one. From Google ADK agents. We're going to use an LLM agent in this case. I might also use the agent class. I'm going to leave that as well. And then Google's ADK also has built-in functions for dealing with MCP servers. So ADK tools, MCP tool, and then we'll do MCP tool set in this particular case. We're going to import a couple different things from this about the MCP toolset itself and the connection type that we're using. Awesome. So the next thing I'm going to do is I'm going to kind of initialize my tool set. So I'm going to kind of define the connection back to my MCP server. In this case, I'm just going to have it running locally as a file, but I would do much the same if I were initializing it with an MCP server that was running on a server. Instead of providing the file address, I would be providing the actual URL to the server. So I'm going to create a tool set. Using the MCP toolset definition here and library here. So we have some connection parameters that we're going to define out. In this case, we're going to have it run a command, Python 3. And then for arguments, we're going to have it open our MCP server here. MCP server.py. Perfect. Got a closing parentheses there, and that should be good to go. So now we've defined our tool set, and now we need to define our root agent. So in ADK, you define a root agent that's going to kind of be the first agent that users are talking to as a part of a conversation. You might then choose to hand off to various sub-agents. Sub-agents can be super useful in that they're provided with different system instructions. And they optionally can also be provided with different MCP servers, different tools in order to kind of help improve tool choice accuracy. So I'm going to define a root agent here. We're going to use the LLM agent class for this. I want to tell it what model we want it to use. Let's do Gemini 2.5 Flash. For this example, we're going to give it a name, just call it assistant. Provided a description. These are more helpful whenever you are kind of creating an agent card for exchanging information about what different agents are available in the A2A protocol. In this case, it doesn't matter as much. But what does matter is our instruction. This will be our system instructions for this agent. Let's just say you're a friendly assistant answering questions about the ISS. Perfect. Let me make sure all my files are saved. Let's see what this doesn't like. That should be a curly brace, not a. Oh, syntax. And now I reference my other code to make sure that I'm not crazy about my syntax here. I'll just copy and paste this over. There we go, that looks a little bit better. Perfect. And now let's initialize things with ADK here. What did I do to you? So if I run the command ADK web, it's going to run a local web server. Oh, not ADB, ADK. So what this is going to do is it's going to run a local web server on my machine. This is kind of a great developer environment for doing testing. I'll click on that real quick. And we get this web interface environment here. So from here, we can kind of select what agent we want to play with. So we just made ADK agent demo. And then we can send a message to it. So where is the ISS right now? Then hopefully we don't get errors. Let's try this again. So we select our agent here. Where is the ISS right now? And we can see that the model has decided it wants to go call a tool. We can kind of see exactly what happened here. So the assistant went out and called this tool that it has access to, get ISS position. We have all of kind of the content parts that we can use for debugging this. This is part of why I love the ADK framework. It gives you all the information to help debug. We can see the requests that it made to the MCP server. And then we can kind of see the response. It decided to go and call that function. We can see more information about the event, so we can kind of see the exact information that our API gave back. So successful API call, this is the position. It fed that information back to the LLM, and then the LLM produced a nice, natural language response to our user. So the ISS is currently located at these particular coordinates. Let's try the other function we have. So who is currently on board? Again, it correctly decided it wants to call the get ISS crew function. It goes and gets that information. And it gives us a nice formatted list of the crew that are currently on the International Space Station. So that was as quick as I could go, 0 to an MCP server and an agent in less than 30 minutes. A couple of takeaways that I have for y'all. Let me get my slides back here. There we go. Learning resources that I want to leave y'all with. Agent Development Kit is a fantastic framework to build with. If you want to scan this QR code, or you can go to goo.goal/ADK. That'll take you straight to our GitHub documentation page for ADK. There's a lot of great sample applications, quick start guides, tutorials, and just explanation on how all of these pieces work and how they work together. Really great place to get started building. Another great place to get started building with Gemini and just Google Cloud AI in general is our generative AI GitHub. So if you scan this QR code or go to goo.goal/GenAI GitHub, this will take you to a place where you can kind of review a bunch of code samples and sample apps using our Google GenAI SDK and all the various kind of components therein. If you're interested in kind of staying up with Google, hearing the latest about what we have going on, we have something called the Google Cloud Innovators Program. If you sign up for this, you'll get emails whenever we have events in your area, and you'll also receive our developer newsletter. I believe it's called The Overwhelmed Person's Guide to Google Cloud. And that's published every, I think, week or 2 weeks, and it has kind of all the latest information about what's new from Google and how people are using our tools in order to create awesome things. Also, just a quick plug from myself. I'm from the Google for Startups team, so I support startups kind of on their journey from idea to inception and then hopefully to IPO. The Google for Startups program provides credits as well as kind of business and technical support, community and kind of co-marketing and mentorship. If you're interested in kind of learning more about the Google for Startups program, I'm happy to chat with you. Find me throughout the event. And here's a QR code if you want to connect with me. Thank you all so much. I appreciate you being here.